I'm Lauren, and Paul and James. I'm just going to go over the play and rules of the game real quick, and then we'll talk about the algorithms, and then we'll have a demo. These are the rules. You will play as the light player against an AI dark player. You'll control a light source, a bunch of sprites, and prisms which redirect light, whereas the dark player has eyes and shades, which, in order to win, you will have to give your sprites and prisms enough light to move around and attack the dark player. And you'll have to blind the dark player's eyes. You'll lose the game if your units are blinded for more than a certain amount of time. This is a screenshot of a game in progress. That is the light source, and each of these small objects is a prism which can redirect the light. And you can see the light source is sending light particles out to blind the shades, which are red when they're alive and blue when they're blind. The sprites are dark blue when dead and yellow when alive. In this image, the sprites are running towards the light source to try and defend the eyes and keep the light player from attacking the eyes.
Yeah, thank you. So for making this game, a developing environment that we used was processing, which is basically coding in Java. And on top of processing, we also used physics 2D engine called Box2D, which is an extension of JBox2D, a Java version of Box2D. And some of the characteristics of this physics engine is that, first of all, to create a game, you create a world. And that this world is like the playground for creating the game. And on top of that, you have to create different bodies and give different characteristics to each of them and attach that bodies to the game itself, to the world itself, so that it can be made playable, it can be killed, it can be generated, regenerated, and things like that. So this is just a basic class diagram. I didn't put like all the methods and variables in there because there were like more methods and more classes for us. So these are just some of the important classes that we had. As you can see, there is a Box2D environment physics engine that we used, and our light and shade class extends from that Box2D. And there's a class called GameState. We just implemented one stage, but if you want to implement more than one stage, then all you have to do is make instances of this GameState and put characteristics in each one of them so that you can create different stages. And on top of that, I was talking about the bodies and everything. These are like shades, prism, sprite, eye, light system, light particles that Lauren was talking about earlier. All of them are extended from a class called particle, and all of them are a body that's attached to the game state. And the game state is, as I said earlier, the stages that we can build. Other than that, we have AI players, which is a class used to manipulate the animal units, AI for the animal units, and there's a contact listeners class which implements what happens when different characteristics collide with each other. That being said, I'd like to pass it over to Paul, who will be talking about demo.
Alright, I'll show you guys the demo. So, we're going to start off by trying to move the light switch right here. I'll choose the mouse here. Okay, and we can rotate the angle of we can rotate the angle of the light particle spray, shall we say, using WASD or using the arrow keys. We basically want to redirect the light so we can light up our other units before if your units are left unlit for too long, you end up losing the game. So you want to light them up first. So I'll just show you guys how it's done. So the screen is actually going to slowly get darker as the units stay unlit. But we're going to just try to keep all of our units lit here. So right now I'm shooting these light particles at this prism, and I can use the prism to redirect the light. So I can also change the intensity of the light. So I can redirect the light using the prisms here. And to do it right, you can do something like this. light off your other prisms, redirect that, and then light up more of your units. So if you want to move your units, you just you can do a selection box. You can just click on them, and if you right click, that'll move them wherever you want. And also, if you have multiple units, so like you can rotate them all at the same time. That's kind of weird. You didn't really expect that to happen, but so we want to try to blind these eyes over here by just continually shooting light out at them. But the AI is trying to block us randomly. But every time you light up an enemy unit, it'll be blinded, right? And it'll just stay still. And you can manipulate the unit by using one of these small particles right here. Just move it slowly. It'll approach. As long as it's blinded, it should attach, and you can actually move it out of the way. So basically, these little red dots here, they're just gonna get in your way. So you're gonna move them out of the way, or you can just kind of brute force your way. Just ran into them. And goal is to blind the eyes for, I believe, 5 seconds. 5 seconds. I don't know how long that will take me, actually. Feed the AI over here. Should do it. And there you go. Victory. Also implemented few menus, pausing, stuff like that. It's not really that important though. Pause and pause, pause and pause. Reset. Whatever. Wait, go back to the main screen. Etc. Anyways.
Okay, so I'm going to talk about the AI that we did implement and some of the things we learned on game day. So we plan to have AI that uses a vector field kind of influence map that would track the amount of light on the screen, and the AI would base its decisions on how much light there is. And we also would split up the decision making into a bunch of little parts, and it would choose between which ones were most valuable at the time. So this is kind of like what the influence map would look like. We actually have this partially implemented, but in the demo it's turned off. So as you can see, the idea is that each cell would store the amount of light that's been over it fairly recently, and the average direction that that light's been going, so that they would be able to arrange the shades, which are these little red guys, to intercept the light and push into the player. Here are some of the things that you would have had the AI do for fairly simple verbs. And each one would be broken down into smaller tasks. And these would be fairly simple to implement too. So the AI would be looking at this, and it would be evaluating all these different conditions